Yesterday, a paper was published by an international scientific consortium. This group is called NANOGrav, and they've been using a series of instruments to measure pulsars. The NANOGrav data that was released is 15 years of data from pulsars. Pulsars are neutron stars, which are stars that have collapsed on themselves and are basically super dense and start spinning, basically like a lighthouse. So it looks like almost like a strobe light. We can see thousands of these across the universe, and we can observe them. And the rate at which the pulsing is coming out of these pulsars tells us a lot about what is happening in the space between Earth and those pulsars. And when you collect enough data over a long enough period of time, which is what these folks have just released as 15 years worth of this data, you can start to see really interesting patterns in the data that support the theory that space-time itself is slowly vibrating, being stretched, being compressed, being pulled apart, being pushed back together because of very large gravitational events happening around the universe. You know, that kind of two-dimensional image of a black hole where it looks like the middle of a black hole, space itself collapses in and it collapses down. And what happens is space and time get significantly elongated when they're really close to gravity. Gravity actually pulls space, sucks in time, and it becomes distorted. And so when you have large black holes around the universe spinning and running past each other, they're actually pulling and stretching space-time itself, and that sends out ripples throughout the universe. Ripples that are slowly undulating space and time itself. So by observing all of these pulsars around the universe and the rate at which these pulsars are pulsing and seeing slight variations, we can start to measure and actually see those very slow waves of space-time itself undulating and being pushed and compressed. And so it supports Einstein's general theory of relativity, which indicated that space-time itself can be warped by gravity. And it provides a really interesting picture on the universe itself, that all around us, we have large masses that are many, many millions or billions of light years away that are creating waves in space and time itself that we as humans will never kind of observe, realize, or feel ourselves, but as part of the fabric and the underlying nature of our universe, with space and time being slowly warped and slowly elongated, slowly compressed. And it's a really fascinating picture of the universe. Over time, as scientists gather more and more of this data, it will provide insights into where in the universe these massive black hole events may be occurring, and also provide insights into the early picture and the large-scale structure of the universe, which helps us better understand how everything started and where we're all coming from.